Welcome to the distributed cache concept video. As part of this video, we are going to learn about what is distributed cache and what is the background of distributed cache. First of all, let's look into the simple problem of web application where client can ask some information to the server, servers fetch the information from the database, returns back to the client. Here the problem is that client can ask the same information again and again to the server. Server, instead of identifying that the request was already served, it will always looks for the database and fetch the information from the database and give it back to the client. That means here the server is eating database every time, which we can avoid in certain cases. So this hitting database every time can be avoided if the server have some intelligence to identify that it already serves the request. So that intelligent we can inject by using in-memory cache concept. So in-memory cache concept where server have the cache inside it, whenever client requests some information to the server instead of looking to the database directly, it will first check into its own cache. If the information is available, then it will returns back. Otherwise, it will hit the database and fetch the information from the database and it stores into cache and returns back to the client. So that the stored information in the cache can be served whenever same request comes from the client. So in such a way, the cache, using the in-memory cache, we can reduce the response time and decrease the load on the database, and also we can save the costs because when you deploy your web application into cloud or when you use the web cloud databases. And also one more advantage using the in-memory cache is that it's very easy to implement and easy to maintain as well, because a lot of languages like Java, .NET, Python having support of in-memory cache concepts, and we can easily implement and easily maintain as well. But the in-memory cache also having some problems. First problem is it is having limited memory because it is sharing the same heap memory of application server. So it's having a very limited memory. It's very impossible to store large data sets. Of when we are going to cache the large data sets, it will be a big constraint. Second problem of in-memory cache is that it will be prone to server failures or restarts. For example, server fails, then entire cache data will be erased because it's the cache information itself is available onto the application server heap memory. Server restarts also same case. The cache data will be lost. And when we do the horizontal scaling of the application servers, then it will become more complex. Let's see that. So now here the application server is horizontally scaled with three different servers, server 1, server 2 and server 3, and added behind a load balancer. Now whenever client requests some information, load balancer will decide to which server that request can be redirected. For example, let's take a scenario where client 1 requests some information to the server. Load balancer redirects that request to server 1. Server 1 will looks for its cache. The information is not available, then it will fetch from the database and stores into its cache and sends back to the client 1. Now client 2 came and it will ask the same information which client 1 was requested earlier. Now load balancer directs the clients to request to the server 2 instead of server 1. Now server 2 having no information about it because the server 1 serves that request which was cached. Now server 2 don't have any information, so it will directly talk with database and fetch the information and stores its cache and give it back to the client. That means we are not able to avoid the cache miss scenario completely when we have the horizontally scaled application servers with in-memory cache. And also one more problem, we can see that it has high risk of data inconsistency, because for example, if you see client 2 is trying to update the information which is stored onto cache, load balancer redirects that request to server 2 again. Server 2 will update its cache and as well as database, but server 1 still holds the same stale data which was served previously. So that leads to data inconsistency between the various caches of servers. So to avoid that kind of problems of in-memory cache, the global cache concept came into picture. So in this global cache, the cache concept will be completely moved out of the application servers. So there is no concept of cache in the server 1 or server 2 or server 3. That entire cache is separated into a separate service that is called as cache service. In real time, it can be Redis or some other CouchDB, some other database, some other cache services. But that cache service is completely out of the application servers here. So advantage of this is it assures the data consistency, because so whenever there is a request from client 1 or client 2, that will be redirected either to server 1 or server 2. It will always go to the cache service itself. So there is no separate cache for server 1 or server 2. The server 1, server 2, server 3, all the application servers are sharing the same cache service. So there is data consistency and there is no cache miss concept. And this survives in case of application restarts also. Yeah, because cache service is separated from the application server, there is no impact on the restart of application server or failure of application server. And it's feasible to store the larger data sets up into the cache service. So yeah, using this cache service, because it's a separate service, there is no memory limit. We can extend the memory capabilities of cache services. Then we can store the larger, we can cache the larger data sets as well. And also we can select the caching strategy, which we'll talk in next video session. But we can use the different caching strategy based on our application needs. Caching strategies we can detail out in next video. But this global cache also having some drawbacks. We'll see the drawbacks one by one. So single point of failure. So whenever the global cache fails, then entire your cache data will be gone. Whatever server 1, server 2 or server 3 stores the information into the cached the information into cache service will be gone. So it will be like single point of failure. So to avoid that single point of failures, most of the times we have to do replication of the cache service. But these replications will become headache when you have the larger data sets to be cached. To avoid the problems of global cache service, the distributed cache concept came into picture. Here in the distributed cache, we have multiple cache services instead of having single global cache service. And the data inside the single global cache service is shared or splitted into different multiple cache services. For example, here cache 1 service can have the cache data name starts with A to D, and the cache 2 service can have the cache data name starts with E to H, and the cache 3 service can have the data name starts with I to Z. Here I told example of naming strategy, but we can use different strategies to share the data between the cache services. As the data is distributed among the different cache services, we need load balancer to identify and divert the request to correct cache service. Using the distributed cache concept, we can build highly scalable applications. And also, one more advantage is that there is no single point of values when we use distributed cache. Because, for example, if cache 1 service fails, then there is no impact on cache 2 and cache 3 services. Only one problem with the distributed cache is that to achieve high availability, we need to implement replication. The high availability is very much important when you are going to build mission critical applications. So using the replication strategy, we can achieve the high availability in distributed cache. So now I have selected the replication strategy of master slave concept, where master service will serve the request of clients, and the slave service works as a demand, and whenever there is an update in the service will automatically update the slave services, or else master service can have scheduled wise updates like hourly or yearly or for days, monthly or half yearly. Like that, it will update the slave services based on our application needs and demand. We can choose the correct update strategy, so that it will get updates. The slaves and master services are in sync. And also, whenever there is failure in the master cache service, then automatically slave services will elect new master service, and that newly elected master service will serve the requests. So in that way, we can build highly scalable applications using the distributed cache with replication strategy, and also we can build the highly available mission critical applications when we use the distributed cache with replication. That's it about the distributed cache concept. I hope this video is very much informative to you. Thank you for watching.